Okay, so the first thing that I was warned about, I believe that before I send, so Amfore Excel file, it's the same file as this one with CSV, which I sent later, but it contains, I believe, a few more Amfora types. So it's a bit longer. This one is shorter, and it contains just those that are here in images. So here I loaded the CSV, which should have 164 instances and 9 features. So both data sets should have 9 features. If you're using the Excel file, it's also okay. You will just have some additional labels inside, but essentially these are the same data. Okay, so these are the metadata, and here I have images, so 164, and I'm using merge data. So one thing that's well, just a short explanation. So here I have data and extra data. So merge data can work in several different ways, but here we're taking images as the base data set, and we're just gluing additional data onto it. So this is the first option, append columns from extra data. We'll just use whatever's in the first table and add information from the second. So if we had more data here and use, let's say, concatenate tables, the table on the output would have so a union of these two data sets. But now we are just using not like an intersection, but basically just whatever is in the first data table. And we merge by image name, and maybe some of you have name here if you're using Excel, but that's also fine. So here on the output, you should have 164 images. Well, rows, actually. And in select columns, I just showed you before that you can remove features and just put them here in meta features. So we remove this easily. And now, so the task is, can I automatically classify images? And to do this, of course, we need image embedding. So now we're not using painters, but Inception version 3. So just this is a standard embedder I would use for typical tasks. Okay, so observe confusion matrix and determine which model is better to use in practice and why. So here in the example, I used logistic regression, KNN, and SVM just because they are typical classifiers used for image analytics. But feel free to use any classifiers you want. So, okay. Great, so now we got the results. So here are my models, KNN, SVM, and logistic regression, and I see that most of them have solid scores, like AUC is high, over 94, well, 0.94 for all of them. Classification accuracy is also pretty solid. So here, I'm not sure how deep you went into these scores, but looking at AUC, so if I'm sorting it here, SVM would be the best. But in terms of classification accuracy, logistic regression is better. And then we also have some additional scores. So F1, precision and recall. So these are important. I wouldn't go into these scores too much, but for example, precision would be how well you identify positive class. And for example, positive class in medicine would be if a person is sick, right? So in medicine, we're usually trying to predict if a person has the disease or not. And the positive class would normally be a person having the disease. So precision would be an important measure to consider, because I would prefer identifying more people as sick just as a precaution and sending them for further tests rather than missing some sick people, right? So for different tasks, you would optimize different scores here. So either SVM with a high AUC or logistic regression would be good, because logistic regression has a bit better scores here. KNN is also pretty solid, but let's just try to decide between these two. So confusion matrix, right? This will give us an idea how the classifier performs. So here, I'm sure Blaž explained this. So here I have actual labels, so the true class, actual, Dressel, Galois, and K-Amphori. And here at the top, I have some, the label that the model predicted. So on diagonal, I have correct classifications, and off diagonal, I have misclassifications. So here, observe confusion matrix and determine which model is better to use in practice and why. So this is, maybe I can do it like this, right? So have two confusion matrices just to show them side by side. So SVM and logistic regression. Okay, so which one would you use in practice? Logistic regression or SVM? So maybe the answer here is not entirely straightforward, but what you can see from here. So one thing is, how accurate are these models? So logistic regression, for example, it misclassifies 20 instances, right? So 9 plus 1 plus 7 plus 3 is 20. This one is 15 plus 4 is 19, and this is 24. So in terms of how many Amfore are correctly classified, I would say logistic regression is better. Also, what's important here, SVM has some kind of bias, let's say. So it fails on one class. Which one? Yeah, on Galois and also key. I mean, mostly Galois, right? So here we have 15 misclassifications. And it's biased towards Dressel. So, you know, sometimes when it gets confused, it just says, okay, it's Dressel, even though it's Galois and key. And here, logistic regression is slightly more accurate in this sense, right? So it has less wrongly predicted Amfori, and it also has less bias towards Dressel. So, you know, if I was to choose a classifier, I would probably go with logistic regression based on this information. Okay, which type of Amfora is the most difficult to predict? We already answered this. Well, here, so Galois is kind of confusing. Let's look at KNN. It also has a higher number of misclassifications here. So I would say that Galois is quite confusing for the model. And now a very important question: how could we improve the performance of the model? So select different misclassifications in confusion matrix and explore them in image viewer. Okay, let's do this. So let's say I went with logistic regression, and I'm using, okay, I'm gonna connect image viewer. So now I'm gonna select this problematic class, so Galois that are identified as Dressels. Why do you think these Galois Amfori were classified as Dressels? Is it the shape? Is it like the handles, the body, the base here? Okay, let's look at typical dressels, right? So what I would say is typical from my perspective, of course, is non-expert, is maybe this bottom part that's quite pointy. Okay, not here, but just, you know, as an amateur here, I would say that this base is kind of like distinctive maybe for dressel, and not so much the body, because here I have these long ones and some round ones, some hearty one, like heart-shaped ones, or, you know, this is a round one. So yeah, Galois would, they're rounder, right? They're more like circular and bigger, right? They're not as oblong, like, okay, one, but dressels are more like they're narrower, if I'm not mistaken. Okay, so I like that you mentioned the weights, right? So maybe handles, okay, let's pretend that handles are super important, right? And just by looking at the handle, you can determine the type of amphora. So this is what models would actually do, right? They would take, so provided that image embeddings reflect in some way also the handles, so maybe one or two or a combination of features describe the handle, logistic regression would be able to then say, okay, only handles are important for distinguishing between amphora types. And you can observe this, you observed this with nomograms, or you can just use a data table to look at coefficients from logistic regression. And this is what you would get. So, for example, if I wanted to say what is important for dressel, okay, I need higher numbers here, you would see, this feature, N 1000 something, is important. But okay, this like the coefficient is quite low, so it probably is a combination of features. The problem here is, of course, that these features are not, I mean, it doesn't say that this is the handle, right? It's just some kind of abstract feature. So that is a problem, because this is not explainable, at least not to us. But now a lot of progress has been made in explainable AI, so I'm pretty sure that in the future, that like quite near future, we should be able to expand Orange with some explainable methods as well. But going back to our images, so what can we do to improve the model? So how could we improve the performance? So I would say that the most, there are two things that I can do to improve performance of these models. No, actually, no, it's not that easy, but it would be just have more images. So here you see that, so in box plot, we have 83 dressel images, 42 Galois, and 39 key images. Okay, so this is not a lot, especially for a complex data set like this. So complex in terms of, I mean, from just looking at an image, it was, even for you as experts, difficult to determine, okay, what is distinctive for dressel and what is distinctive for Galois, right? So perhaps having a higher number of images, I mean, likely having a higher number of images would result in a better model. And of course, there are more than 3 types of amphora, but a lot of other types didn't have enough samples. So if I have just 3 or 4 images for a category, it's almost impossible I will find a distinctive pattern in that image. So I would need probably more images here, which I understand in archaeology is not easy to do. So maybe that's one slight limitation. But what we could do, I mean, again, okay, maybe not super easy, but it's possible. So either have more data here, but I think what would help even more is to train the embedder on archaeological data sets. So here, for example, we could train a specific embedder, just like it was trained for painters, to recognize archaeological artifacts. Now, we go back to having the data set to do it. So image embedding requires a lot of images, right? So to be able to really precisely define or precisely describe the image, we would need, like 1,000 images of one type at least, which is very hard. But if, perhaps maybe the entire global community of archaeologists comes together and we find 1,000 images of Dressels and 1,000 images of Galois, it would be possible to train embedder specifically for archaeology. And this would result in better descriptions. So such an embedder would be able to describe the handles, the body, the base, the rim, and so on from these images, right? And this is how we would get better results. No, what image embedding does for all the images is it scales them to, I think, 200 times 200 pixels. Mm-hmm. So this is what all of these embedders do, is they scale the images internally. So all of these images would be like equally big, but they would be how to say, skewed, because of course this is a long image. So if you put it to a square, it would, of course, it has to be extended like horizontally, right? So I would say that in some way this would be, embedding would be able to reflect it, but you're right. It doesn't know, like these are all bigger than some other Amfore. Yeah, we could so we could scale them to the same size, right? But what we could also do, right, is just we have this in metadata, right? The height and the width of this type of Amfore. The problem here is the following. So this is the height here. So here you have, it's somewhere between 99 and 120 centimeters. And so Orange, now it said, okay, this must be, I don't know what this is, right? It's not a number because, what is this? It considers it a text because it has this dash in between. So this data would have to be transformed in some way. As I said on the second day, when we did the pre-processing, right? I would transform this data. Maybe I can take the average height, expected average height of Amfore, and here as well, right? Maybe I can have two columns, maybe the minimum height and the maximum height, and the same here. So I would have to transform this, and the same for diameter. I would have to transform this to numbers. And then I could add this information here to features, and they would be added to embedding, like to this vector of images, and considered in test and score. So I can, just for fun, I can try doing this, but You don't have to do this because it's a bit of a hack. So let's see what happens. Okay, no, I have to do it before. Let's do this. Okay. So now I'm trying to extract just, will this work? Yeah. Oh, okay. No, still. Okay, now it works. Wow. Okay, this was painful. But what we should get is this. Okay, so now I just, for you to observe, I just extracted the first number here, right? So 73, 68, right? So this is the minimum height of Amfora. And I could just use it here as a feature, as an additional feature. And let's see what happens, just for fun. So ideally, I would transform this into actual numbers, and then Orange would be able to work with these numbers and to build models. Okay, it's a bit better, just a tad. So I would assume that you can use, so probably you would be able to get a better model just based on this metadata, right? But the idea here is a little different. So what if you don't have metadata? What if you just have the image? You know, you find this image somewhere in the archive. It has no labels, nothing. It's just an image. You don't know anything about it, right? So here the idea would be, can I use just the information I get from the image to infer a classification model? Okay, in the final test, there are 3 new images to predict. Use Amfore predict and load it with import images, and so on. So here I have my 3 Amphori, and they're like this. So they're from a different, I think, a different collection. At least the scale is a little different than here. So, you know, they're not, I made sure that these are not in the training data, these exact images. So now I need image embedding, inception version 3, just here I need to set it to the same embedder, and here I will use predictions. So these are the results. Based on these 3 images, 2 were correctly predicted by logistic regression and 1 was misclassified. So this one was labeled as Galois, even though it was actually key. So this is the image that I'm referring to. Okay, but I mean, I would say that the model is not so bad, right? I mean, just with this small data set, it was able to predict 2 out of 3 images. I mean, it's okay. It could be better, and we saw, I mean, I told you how we could improve the model, but for now, I mean, just with this simple collection of images, this was pretty okay. The idea here was to just get you familiar with the procedures of machine learning, so clustering, classification. Blaž talked a little bit about regression, which is predicting numbers, not categories, and we saw a bit of image analytics, because, you know, as archaeologists, you would probably also work with graphical data, and we saw a bit of like how to observe geolocations, because that's also relevant. But this is, so the important thing was for you to understand or get to know the range of techniques that we use, and see in some shape or form how they apply to archaeological data. Of course, the biggest task would be how to adapt like how to use pre-processing for archaeology, and how to adapt some procedures to better work with your specific data. I would say, because I'm an anthropologist by training, and I know that for anthropology there's virtually nothing for now in terms of computational methods. And I would say that, I mean, I know that archaeology is the best in our field, like the broader anthropology, right? Because you have the most data, but still I think that a lot can be done for like using machine learning and data mining for analysis of archaeological data.